Hello everyone. Let's solve Q3 of the Leetcode contest for 68. So this I couldn't solve it in the given time because I just didn't get the approach for it. But then I did look at the solution and I found that it wasn't that hard. So here we go. So split and merge array transformation. You're given two array nums1 and nums2, each of length n. You may perform the following split and merge operation. Now note that the wording is a little confusing here. It's not exactly split and merge. So what you're supposed to do is you're given an array of numbers. Let me open my paint. Okay. So you're given an array of numbers. So let's say 3, 1, 2. Now what you're supposed to do is you can pick any subarray. Okay. You can pick any subarray and insert it in anywhere in the remaining part. So let's say we pick the subarray 3. We would be left with 1 and 2. Now we can insert 3 here, here. Okay, yeah, you can insert it here, here, or here. So that's 0, 1, or 2 in that index, right? Now, if we insert it, let's say this is the input array, and what we're supposed to find, what we're supposed to get is 1, 2, 3. That's the result we need. And then, so we need to find the least number of operations where we pick a subarray and insert it somewhere else. So here, let's say we pick 3, and then we insert it at the end. So that would be the 3 would come here, and that's one operation. So the result would be 1 for this input, right? Okay. So yeah, the result would be 1. And if you look at the second input, it's 1, 1, 2, 3, 4, 5. Okay, what's this? So 1, 1, 2, 3, 4, 5. And the result we need is, where is it? 5, 4, 3, 2, 1, 1. 5, 4, 3, 2, 1, 1. And for this, what we have to do is, in the first operation, let's pick, what do we pick? We can pick 1, 1, 2 and insert it. There are multiple ways to do it, but this is what they've given in the example. So they've picked 1, 1, 2 and inserted it after 4, right? Yeah. So it's 3, 4, 1, 1, 2, 5. And then they've picked 4, 1, 1 and inserted it after 5. So that would be uh 4, 1, 1. Yeah. Okay, so that would be 3, 2, 5, 3, 2, 5, 4, 1, 1. And after this, it's, yeah, we just take out 3, 2 and insert it after 4. So that would be 5, 4, 3, 2, 1, 1. So this is the most optimal way to do it, which would give us 3 operations. So the result is 3. And now what we can do is if we look at the constraints, we note that the maximum length of the array input is 6. So the time limit won't be a problem here. So what we can do is we can brute force it. Okay. Now I'll write the code and explain it along the way. This is sort of like a breadth first search approach. Okay. And the first input would be, let's declare start and target as, okay. And now in our queue, let's have, uh, so we're going to have a queue with our input. Initially, we're going to have the whole input, which is 1, 1, 2, 3, 4, 5, which is the total, the nums. And along with the steps, we we need to get this nums, right? So initially, we're going to start with 0. So that would be start and then 0. Okay. And then while queue, what we're going to do is we're gonna pick all the subarrays of the given input. So 1, 1, 1, 1, 2, and then all the subarrays. So for that, what we'll have to do is range n, and then for j in range I plus 1 up to n, I guess, n plus 1, I guess, yeah. Right. First, let's pop the nums comma steps is equal to q dot pop. And then, so if nums is equal to our required target, we just return steps. And we also need a visited, I think. Do we need a visited? Okay, visited might save time, but we don't actually need it because we're eventually gonna come up with a result anyway. We don't need a visited, but it will save time. So let's just add it. Uh, so if nums in visited, then we continue. If not, visited dot add, and we add the tuple of nums, which is already a tuple, right? So the tuple. Oh yeah. If we get an error, let's. Yeah, it is a tuple. Okay. So let's say, oh, is the index fine? So in the end, yeah, I think it's fine. So what we need is, so our middle is equal to, okay, let's say what we're picking is equal to nums of um I to j, right? And the remaining is equal to nums of up to I plus nums up to, one second. Okay, so our remaining would be from j up to the end. Yeah, because j is exclusive here. And after that, we need to insert it. Insert what we've picked everywhere in between. Now let's look at the list methods in Python and see if we can just insert it. Oh, we don't even need any methods. What am I doing? So for k in range length of the rest, okay, what we're going to do is, okay, so let me just, so let's say it's 1, 1, what is it? 1, 1, 2, 3, 4, 5. Okay, so the indices are 0, 1, 2, 3, 4, 5. And like, we picked 1, 1. So the 1, 2, 3, 4. Okay, 0, 1, 2, 0, 1, 2, 3. It's a bit messy. So yeah, this is the index of the remaining. Now, if we have to insert it here, so our new is going to be uh, rest of 2k plus pick plus rest from k onwards, right? And then we need to add this new to the queue. So queue dot append tuple of new, and this is also a tuple of new, and then along with the steps plus one, because there's one extra operation we've done. Yeah, and then that is it, I guess. Let's give it a go. Cannot unpack non-iterable. Let's print out the queue and see what's going on. Okay, why is temp 0 here? Okay, that's because, wait a minute. Okay, there's some should convert this into a tuple. Q append start comma 0, and it should be fine now, hopefully. Okay, that is fine at least. So this is q.pop. Let's get rid of this and see what's the error now. Okay, q.append. First of all, let us pop left. Q.pop left, I guess. Yeah. Yeah. So I was appending and popping from the same side, so that was the problem. And let's see if this works. Yeah. So that was the solution. Essentially, what we're doing here is we have our input, right? We have our input 1, 1, 2, 3, 4, 5. And we're picking all the subarrays of this. That, all these, and then all the twos, all these, and then all these. We're picking up all the subarrays, and then we're inserting it everywhere. And every time we insert it, we get a new permutation. And this new permutation, we're adding it to the queue, along with the number of steps we've taken to get that permutation. And after that, if this new permutation is the target we need, then we just return the steps. Yeah. So that was a solution. Obviously, the time complexity of this is really, really huge. But since our input size is just 6, at most 6, it doesn't really matter. So, yeah, that was a solution. Thank you for watching.